All right, let's skip the boring theory. Today, we're going to do something fun. We're jumping straight into a real design session. We're building the storage for a brand new app from scratch. And guess what? You're on the team with me.
Okay, so picture this. You've got this amazing idea for a new application. You're all fired up, ready to build it on AWS. But right away, you hit this massive question. Where are you going to put all the data?
And, this isn't just some small detail. If you get this wrong, it can absolutely crush your app's performance. It can stop you from scaling up, and it can just quietly suck your budget dry. But if you get it right, that's when you're really set up for success.
So to make this super practical, we're going to design the storage for a made-up photo-sharing app. We'll call it Snapstream. And that's right, you're on the architecture team. Our mission is to make the right calls right from the very beginning.
All right, team. First things first. Let's talk about the most obvious part of our app. All those pictures, maybe videos, and all the website files, the stuff our users will actually see and upload.
So here's our first design problem. A user uploads a new photo. Our website itself has logos, style sheets. Where does all that stuff actually live? Because it turns out all these different files have pretty similar needs.
Okay, let's break down exactly what we need here. Number one, high durability. We can never ever lose someone's photo. That's a deal breaker. Number two, infinite scale. We're dreaming big, right? We want millions of users, so our storage can't just run out of space. Then we need direct web access, so a browser can just grab these files without any fuss. And last but not least, it's gotta be low cost, because we're gonna be storing tons of this data. Terabytes, maybe even petabytes down the line.
So when you look at that list of requirements, it points us straight to one particular type of storage: object storage. And honestly, the best way to think about it is like this. Imagine a giant, magical warehouse for your files. It's infinitely big. You just hand it a file, it gives you back a special web link, and it basically promises to keep that file safe and sound forever.
And when you're talking about AWS, there's really only one name that comes to mind here. The undisputed king of object storage is Amazon S3, that stands for Simple Storage Service. It checks every single box we just listed. Perfect, so boom, decision one is made. All our user photos and all our static website stuff, it's all going into S3.
Awesome. So our pictures are safe. But what about the real heart of the application? The database that's going to store all the user profiles, the comments, the likes. This kind of data has a completely different list of needs, and it all boils down to one thing, really: speed. Okay, so that brings us to our next big question for the team. What kind of storage are we going to hook up to the server that's running our database? This is the engine room of Snapstream. We have to get this right.
Now, what's so interesting here is just how different these requirements are from before. We need ultra-low latency. We're talking lightning-fast reads and writes, because nobody's going to wait around for a page to load. We also need high throughput, so it can handle tons of operations all at once. And here's the key part. This storage has to be tightly coupled, basically physically attached to one single server, acting like its main hard drive. This is the textbook example of where you need something called block storage. So if object storage was our giant warehouse, think of block storage as a super fast internal hard drive that you just plug right into your server. It gives you raw, dedicated, high-speed storage. And for this job, the clear winner is Amazon EBS, which stands for Elastic Block Store. We can literally dial in the exact performance we need, create what's called an EBS volume, and attach it right to our database server. It is the perfect fit. All right, decision number 2 is locked in.
Okay, we are making some serious progress here. But let's be real, Snapstream isn't just going to run on one server. To handle all the traffic we're hoping for, it's going to run on a whole fleet of servers. And that introduces a brand new and very common challenge. So how do we make sure that every single one of our web servers can access the same set of shared files? We're talking about things like configuration files, or maybe some shared assets, or even log files that we need to put in one central place.
This problem is solved by our third and final category, file storage. And the easiest way to get this one is with an analogy I think we've all experienced: the shared network drive at an office. The G drive or the S drive is just a standard file system with folders and files that a bunch of different computers can all connect to and use at the exact same time.
Now, in AWS, we've got a couple of main options here: EFS and FSX. Now, FSX is amazing for really high-performance stuff or specific Windows workloads. But for our little Snapstream app, which is a pretty standard web application running on Linux, the choice is actually a lot more straightforward. So we're going to go with Amazon EFS, the Elastic File System. It's simple, it's fully managed, and it lets all of our servers hook into the same file system without any headaches. And just like that, our third and final storage decision is made.
All right, we've tackled 3 different problems and made 3 key decisions. Now let's put it all together and take a look at our final architecture.
And there it is, the SnapStream storage blueprint. Look at that! It's actually a beautiful thing when you see it laid out. We've got all the user uploads and website assets going into S3. Our super important database server is humming along on a high-speed EBS volume, and all of our web servers are pulling their shared files from an EFS drive. Each service is doing exactly the job it was built for. It's perfect.
And hey, to make this all super easy to remember, here's a little cheat sheet. Go ahead and screenshot this if you want. S3 is your object storage for anything you need to scale infinitely. EBS is your block storage for those fast, dedicated server drives. And EFS is your file storage for when you need to share files across a bunch of servers. Simple, clear, and really effective.
So if there's one thing you take away from this, it's this. There is no single best storage service. The whole point, the whole job of a good architect is to really understand what your application needs and then pick the right tool for that specific job.
So look, we've designed an architecture that can scale up beautifully, but I want to leave you with one final thought. What happens when something breaks? What happens when one of these pieces fails? We've designed for success, but have we designed for survival? That's a question for another time. Thanks for being on the design team today.